The case selection control statement. This is a last type of control statement. The first type of control statement is a sequence control statement. Second type is decision or selection control. Third one is looping or repetition. The fourth one is case selection control. That is switch case statement. This is a flowchart representation for case selection. That is switch case. This is expression 1. The condition is the condition case is 1. The code block 1 is executed. It comes here. If case is 2, the expression case is 2. It executes block 2, block 3. So the condition is not meet this case. The defaultly this execute. For example, switch. This is syntax of switch statement. And within a switch, we put integer or character variable. Within a switch, we put only integer or character, not float, double, and all things. So we use only integer or character within a switch block. So it is an index variable. Based on the variable, the case is executed. If the integer values or character values this case, it executed, it break. We need to put break. Otherwise, it fall next case. If we not put break, if the case is this case is true, the execute statement and all, then it come to the case 2 statement also. If we put break, to execute the case 1 statement, then it come out the switch block. The example program of switch case. So this example program to convert the given integer number to word. If we give the input like 473, the output will be 473. If we give input as numeric, it will display as word. So main integer n, d, i, z. These are the variable for input output processing. So we assign 1 to d. Now the d value is 1. Printf, enter an integer number. So if we do 473 min, so we enter 473. The 473 value is assigned to n. The display like enter an integer number. This is information to user. If we type 473, the 473 is assigned to n. Then we assign that 473 into z. Just we hold that value in new variable. We get input 473 through n. Then we also assign that value. That is, we hold the same value in z. So z value is 473. Then n also 473. While 473 is greater than 0, the condition is true. The z value is 473. So 473 is greater than 0, condition true. D equal to d star 10. What is the d value? The existing value of d is 1. We multiply by 10. 1 into 10, 10. The new value of d is 10. Here z equal to z slash 10. What is z? Z 473. 473 divided by 10. Z is an integer, 10 is an integer, yield integer result. So z value is 473 divided by 10, 47.3. 47.3. Because integer yield integer only. So it yield 47 only. 473 divided by 10, it yield 47 only. It truncate 0.3 because integer yield integer. So 47 is assigned to z. Then continue the loop. Now the new value of z is 47. 47 is greater than 0. The condition is true. D equal to d star 10. Already d value is 10. Now we multiply by 10. So the new value of d is 100. Here z equal to already that is the old value of z is, that is existing value is 47. 47 divided by 10. 4.7, but the integer yield integer, so it store only 4. So the new value of z is 4. 4 is greater than 0, condition true. In D, the existing value of D is 100. We multiply by 10. So now the new value of D is 1000. The z value is 4 only. 4 divided by 10, 0.4. But integer yield integer, so it give only 0. The new value of z is 0. Then it come to the check the condition. So the 0 greater than 0 condition is false. It come out the low. Then D equal to D slash 10. Already D has 1000. D has 1000. 1000 plus 10, 100. We change the value of D is 100. The previous value is 1000. We divide by 10, then we assign. So the new value of D is 100. So what is the purpose of this process? Through this process, we find the number of digits. If we enter 473, it rotates 3 times. After this statement, the value is 100. That is 473 means the maximum position is 100. That is 1, 10, 100. If we enter 473, the maximum position is 3. That is 100. If we put 4 digit value, the D will, after this statement, the D will be 1000. If we enter 3 digits value, the D will be 100. With the 4 digit value, the D will be 1000. If we enter 2 digit value, the D will be 10. So based on this value, we can easily find the number of digits. So after that, the while n greater than 0, z only 0, but n the old value 473 is available in n. We change z value only. So 473 is greater than 0, condition true. Now I equal to n by d. What is the value of n? 473. What is the value of d? D is 100. After this statement, the D is 100. So 473 divided by 100. 473 divided by 100. 473 divided by 100, 4.73. But integer yield integer. So the value 4 is assigned to I. Now the value of I is 4. So the first digit is truncated from 473. So I value is 4. Then we change the n value because we truncate 4. So we remove that 4 from n. So 473 modulus d, the d value is 100. 473 modulus 100, the remainder is 73. 473 modulus 100. What is the remainder? 73 is a remainder. 473 divided by 100. What will be the remainder? 73. So 73 is assigned to n. So the new value of n is 73 only. It remove the first digit value 4. The first digit value it truncated and assigned to I. Now I has 4, n has 73 only. Now we reduce the position, the digit position by 10. That is the value of d is 100. Divided by 10, the new value of d is 10. Switch off I. What is the value of I? 4. So switch off I. So in this case we put 9 cases. That is case 0, print 0, break. Then case 1, print ONE, break. Case 2, print TWO, break. So totally 10 cases. Start with 0 to 9. So totally 10 cases is there in switch block. Here we give only 2. In between 2, 7 cases is there. That is case 0, case 1, case 2, case 3. The last case does not require break statement because automatically it comes out. It's not required. Case 0, print of 0, break, case 1. So in this case, the I value is 4. The case 4 is executed. It print FOUR. Then break. It comes out the switch block. Then it continues the while statement. What is the new value of n? 73. We remove 4 here. So 73 greater than 0, condition true. So 73 divided by 10 because new value of d is 10. Because here we divide by 10. Already 100 divided by 10. So the new value of d is 10. The new value of n is 73. 73 divided by 10, 7.3. But integer yield integer. So that 7 is assigned to I. So it truncates 7 from 73. Then here 73 modulus 10. What is the remainder? If we divide 73 by 10, the remainder will be 3. So the 3 is assigned to n. The new value of n is 3. Then we change the d. D equal to d. Already d, the existing value of d is 10. 10 divided by 10, 1. The new value of d is 1. The new value of I is 7. The new value of n is 3. The new value of d is 1. Switch off I. The new value of I is 7. So the case 7 is executed. It print SEVEN 7. The word 7. It comes out the switch block. Then it continue the while block. While loop. What is the new value of n? Just 3. 3 greater than 0. Condition true. 3 divided by new value of d is 1. 3 divided by 1. 3 divided by 1. 3. So the I value is 3. N equal to 3 more or less 1. What is the remainder of 3 divided by 1? 0. Now the n value is 0. But I value is 3. D equal to d slash 10. The existing value of d is 1. 1 slash 10? 0. 0.1, but integer yield integer. So the new value is 0. Now the d value is 0. Switch off I. I value is 3. So the case 3 block is executed. So the display, it print THRE, the word 3. Then it comes out the switch block. It continue the while loop. What is the new value of n? 0. 0 greater than 0, false. It comes out the while loop. So display 473. If you get 4 digits, first it's find out the position of the digits. That is how many digits. Using this process, if 4 digits means the d value is 1000. Based on 1000, so it first truncate the 4th position. That is 1000th position. Then change the 100th. Then it will find the 100th position, truncate it. Then it changes. So in a similar way, it may be 5 digits or 4 digits value, maybe anything. If we enter the numeric values, it display the equivalent word. The it's equivalent words like 473. If we give 473, it will give 4733. If we give 1000, it will display 1000. This is an example for switch case. Tips and tricks for switch case. For example 1, we can use character also. Here in previous example program, we use integer. In this example, we use character also. Character m equal to z. Switch m. The m value is z. So the case z is executed. This block is executed. So display zebra. Then it comes out the switch block. It comes out the main. In example 2, we can use character and integer. So we combinedly, both integer and character we can use combinedly. That is integer m equal to 67, switch m, case k, case 65, case c, capital C, and default. If the 3 condition is will not meet, so the default block is executed. In this case 67, m is 67. No 67 is there, but m is 67. 65 the ASCII, in ASCII chart, ASCII value 65. The ASCII character for 65 is A. The ASCII value, the ASCII character for ASCII value 65 is capital A. So 66 capital B, 67 capital C. M is 67. So capital C is there. So it print cat. So we can use character and integer combinedly, but it compare the ASCII value or ASCII character. Based on that, it select the case. Break continue statement. The tips and traps, another tips and traps for example 3. We can use more case also. That is, in this example, character m equal to z, switch m, case small k, case capital K. Here we put 2 case, but one common block. we put small k or capital K. Small k means this execute print kangaroo. If we put capital K, this case executed print kangaroo. We can write like this. So no brace is required for multiple statement. In switch statement, we no need to put opening brace, closing brace. So between the case 1 to case 2, within the first case and second case, these are the block of the previous case. So we no need to put braces. No braces required for multiple statement. Default case is optional. If we require, we put the default case. But default case may be anywhere in the program, not only in last case. Default case is not only in last case. For our readability, we put last, but we can put middle or first of the switch, first of switch block. So that case, default case is optional. It may be anywhere in the switch block. We cannot be able to write like this. Case I less than or equal to 50. We can write case character or integer. We cannot be able to write like this. Case I less than, that is a relational expression. We put only character or integer. Break is applicable, condition is not applicable. In switch case, we need to break the block. So the condition is if we put K here, and this example is Z. So it comes here. This block is executed and come out. If we put K, small k, the case is executed, then it fall out, then it's kangaroo, then it come the break. If we not put the break, it fall another case also. So to break the block of case, we put break. But break, we can use break to break the switch block. But the opposite statement of break is continue. The two type of statement is available in C. One is break and another one is continue. The break is only applicable in switch case. The continue is not applicable. The continue is only applicable in looping statement. While, do, while, for. If we use looping statement within case, we can use continue. That continue is work on loop only. It does not continue the switch. In switch block, we use only break. Nested switch case is also available. We can write switch case within a switch case. Now we discuss about the break, continue, exit. Here we apply break. Already we apply break for switch case. We can also apply for to come out the loop. Here print of enter a number, scan a percentage %d. So we get one number. For example, if we put 5, it find whether it is a prime number or not prime number. If we put 5, it start with what is a prime number? A number divide by 1 and itself. It is not divide by other. It divide by only 1 and itself. This is prime. If it is divide by other, in between 1 and other and itself, it is not prime. It's only divided by 1 and itself. Otherwise, it's not prime. We get one number. Here we start with 2. Because all numbers are divided by 1. So we start with 2. The n minus 1. The condition is n minus 1. N minus 1 means suppose if we give 5. Here we change as 4. So the I value is 2. 2 less than 4. Condition true. So n value is 5. 5 modulus 2. What is the 5 modulus 2? If we divide 5 by 2, the remainder is 1. 1 is equal to 0. So it give remainder. If we divide by 2, it give remainder. So it's not equal to 0. If it is equal to 0, it's divide. So it's not prime. In our case, for example, if we put 5 modulus 2, it yield the remainder is 1. 1 equal to 0, false. So the loop false mean comes here. Then for is continue, because the for For statement consists of only one statement, that is if. The if is consists of this block. That is immediate statement is a for block statement. If you we can put opening brace here and closing brace here, it's not required because only one statement is available in for loop. So we no need to put opening brace, closing brace. That is a for. The condition is true. It comes here. That is 5 modulus 2. Result is 1 equal to 0 false. It's continue the loop. Now the I value is 3. 3 less than 4. Condition true. The n is 5. 5 modulus 3. The 5 modulus 3 remainder is 2. 2 is not equal to 0. So condition is false. It's continue the loop, outer loop. Then now the I value is 4. 4 less than 4. Condition false. This comes here. So, what is the value of I? Value of I is 4. No, the 4 value is 4. The 4 less than 4 condition false, it comes out. No, here we put equal to. Less than or equal to. 4 less than or equal to 4. The condition is true. They execute 5 modulus 4. The remainder 1, the condition is false, it comes here. The I is incremented by 1. The new value of I is 5. 5 less than or equal to 4. Condition false, it comes out the loop. Then if I equal to n, the value of I is 5. The n is 5. So 5 equal to 5, let's display as prime. It's a prime number. If we execute the same program, if we put 8, let's start with 2. 8 modulus 2. Result is 0. 0 equal to 0. Condition true. So it's divided by 2. So it is a not prime. Here we put break. The break is only applicable switch case and for loop. It's not if. So it is a break. So it break the loop. Break the for loop. It comes out. So already it display not prime. The I values only 2. 2 equal to 8. False. So it not display prime number. It not display prime number. First display not prime only. For what is the requirement of this if statement? If you not give the if statement here, in first case, it rotate. In first case, that is if we give the input as 5, so it rotate divided by that is 2 and 3, 4. Then it comes out the loop. It display prime number. But in next case, it divided by 2. 8 modulus 2 is 0. 0 equal to 0. Condition is true. It display not prime. Then it comes out the loop. If the if flag is not available, it also display prime number. So that's why we put if statement. In second case, if we not put if statement, in the second input, it display not prime and prime number. The first case, if we put prime number, if we give prime number as input, it will display prime number. If we put not prime number as input, it will display 2 output. That is not prime and prime. So that's why we put if statement here. If it is come out, the I value is not equal to n. If display not prime, it comes out. The I value is not equal to n, so it will not display. It completely rotate, so it comes out. So that number is a prime number. So the I and n are equal, both are equal. So it will display prime number. In continuous statement, main integer I equal to 0, I less than 3, I plus plus. This is outer loop. This is inner loop. J equal to 0, j less than 2, j plus plus. Inner loop rotate 2 times. If I value is 0, it rotate 2 times. I value is 1, it rotate 2 times. I value is 2, it rotate 2 times. So for loop change 3 times. 0, 1, 2. For each and every time, inner loop j rotate 2 times, 0, 1. So the first time it initializes 0, 0 less than 3 condition true. So it come to this inner loop for the initialize 0 to j, 0 less than 2 condition true. So I value is 0, j value is 0. So here we put continue. Continue the inner loop. It's not outer loop. Continue the inner loop. So now j changed to 1 because already existing value is 0. Now add by 1. The new value is 1. So 1 less than 2 condition true. But the similar value is available. I will not change because the first time I value is 0, j is executed. There are now j value only change because inner loop only continue. So j value is 1, 0 equal to 1 condition false. It display I equal to 0, j equal to 1. Then it continue the inner loop. Now the j value is 2, 2 less than 2 condition false. It comes out the inner loop. Then it continue the outer loop. Now I value change to 2. The new value of I is 2. 2 less than 3 condition true. Then again j initialize to 0. So j value is 0. I2. So I value is 1. 1 equal to 0 false. 1 equal to 0 false. So display 1 0. It continue the inner loop. Then j is the new value of j is 1. 1 equal to 1. It continued. So both are equal. I value and j value is equal. It continue the inner loop. Otherwise it display. So the output will be like this. That is I equal to 0, j equal to 1. So I value is 0, j value is 1 in display. I is 0, j is 1. J equal to 0, the condition is false, it continue. The condition is true, it continue. So I value is 1, j value is 0. I value is 2, j 0. I 2, j 1. So both are equal, it continue the inner loop. So this example to illustrate the continuous statement only. So then exit. What is the difference between break and exit? Exit is come out the program. It is equivalent to closing brace of main function. It terminate the program. Exit statement terminate the program. Break statement break the loop only. For example, integer a. So it is a typing mistake. Integer I. For I equal to 1, I less than or equal to 5, I plus plus. This loop executed 5 times. Because equivalent to 5, start with 1 and end with 5. So j I value is 1. The condition is true. 1 equal to 3. 1 equal to 3. Condition false. So it will continue the loop. Then 2. 2 equal to 3. It false. Continue the loop. Then 3. 3 less than or equal to 3. Condition true. 3 equal to 3. Condition true. Exit. It terminate the program. It comes out the main block. It terminate the program. If we replace exit with break, does not comes out. 3 equal to 3. Break the for loop only. It comes out here. Break the loop. Then this statement is executed. If we put exit, it terminate the program. If we want to terminate the program in middle of the program, in middle of the main, if we want to terminate the program, just we put exit. Then R loop and goto statement. Now we see about the R loop and goto statement. And this R looping, it is infinity loop is R loop. Within this block, we put statement to come out the loop, to break the loop. For example, S1, S2, S3, these are the variable, that is subject variable, 3 subject. T for total, character another equal to y. So it is a character variable, we assign the small y. While of 1, this is a R loop. This loop executed because in C language, non-zero value are true, 0 value only false. While of 1, the condition is true, always true. So condition is true, it executes this block. Enter 3 subject mark, so it accepts 3 values. Then add 3 values and assign to T. Then it display total mark. A display like want to enter another. So it require one input. That is it is ask one input. That is a character input. If we put y, if we press y, that y is assigned to another. So another has y. Y not equal to y. The new value of another is y. Y not equal to y. Y is not equal to y, false. So false means it comes here, it continues the loop. Then it asks another 3 subject mark. Then it sum the 3 marks. It display the total. Then it asks want to enter another. If we press other than y, if we press n, the new character of that is new character value of another is n. N not equal to y, condition true. So this statement executed, because this is a simple if. The condition is true, this statement executed, this is a break statement, it comes out the loop. This is the loop. This is comes out the loop. So it asks 3 subject mark, add and display. It asks 3 subject mark as input. It sum 3 values, it find the total, it display. Then it asks enter another. If you press y, it continue. If you press y, it continue. Continuously ask 3 subject and it calculate and display. If we press other than y, the condition is true, the break is executed, it comes out the loop. This is the odd loop. The goto statement, this example for goto statement is an unconditional statement. For good programming practice, we don't use goto statement, because goto statement is an unconditional statement. That is, in more cases, goto statement will give the complexity of the program. It will give wrong execution, wrong compilation. So we don't use the goto statement. We use only rare cases to come out the inner loop. If we want to come out the innermost loop, we can use the goto. Integer ij, for this now we see the example, that is integer example program. Integer ij, for I equal to 0, I less than 3, I plus plus. For j equal to 0, j less than 2, j plus plus. If I equal to 1, what is the value of I? Here I value is 0, j value is also 0. 0 equal to, so I equal to 1, 0 equal to 1. That is I value is 0, 0 equal to 1, condition false. J also 0, 0 equal to condition false. In logical and both are false, the result is false. Any one is false, the result is false. So in this case, and this expression is false, this expression, the both are false. So the else portion is executed. So it display 0 0. It display 0 0. Then it continues the inner loop. Then j is 1, 1 less than 2, condition true. I equal to 1, I value 0, 0 equal to 1, false. But j is 1, 1 equal to 1, true. But any one is false, the entire expression is false. So the else portion is executed. It display 0 and 1. First it display 0 0, then it display 0 1. Then it continue the inner loop. Now the new value of j is 2. 2 less than 2, condition false. It comes out the inner loop. Then it continue the outer loop. Now the value of I is 1. 1 less than 3, condition true. Then it start with 0. So I value is 1. So 1 equal to 1, true. But j value is 0. 0 equal to 1, false. So display 1 and 0. Then continue the inner loop. Now the new value of j is 1. I already 1. 1 equal to 1, condition true. Now the new value of j is 1. 1 equal to 1, it is true. So the both conditions are true. The total result is true. The total result of condition is true. True means it is go to out. This statement is executed. The out is a label name. It may be user defined word. We can give anything. In this example we put out. It's not a fixed one. We can write any word. Go to out. So this label is here. Out colon. This is a label heading. We put colon. Here we don't need to put colon, because this is the label heading. Under the heading we give only one printf out of the loop. So go to out. So automatically the control is transferred to this label. By using break, we cannot able to come out the innermost loop. If we put break, it's come out to this inner loop only. It continue the outer loop. If we put break, it comes the inner loop, continue the outer loop. If we put goto, it come out the inner loop without any condition. So it is an unconditional statement. So it is a label name. So it go to here. The controller is transferred to this label. Then it out of the loop. So what is the output of this program? 0 0. It will display 0 0 0 1 1 0. If I is 1, j is 1, the goto out is executed. It will come out of the loop. So if we like to come out the innermost loop, we can use goto out.